Okay, so as you can see, we're starting here in Chief. Now, recently, I've struck up a friendship with Mr. Larry Belk from Texas and Oklahoma, in that general area. And he has construction and design actually in his DNA. He's had uncles and cousins, and he's been doing this since he's been a young boy. And so I found out that he does things very similar to the way I learned in Texas. We had the same terminologies. It was great. And he and I have been trying to figure out how to provide more good information to the builders and especially the framers from Chief Architect. You know, if Chief has the information, we need to find a way to get it out so that it's useful and makes their life easier and more accurate and faster. So we started with and by the way, you can follow along. We started with a building that's 30 feet long and 20 feet wide. So that would mean a 20-foot zero span. And we have a conventional ridge and conventional hips. So that's 1.5 inches thick for both of those. So what that would mean is 20 feet minus 1.5 inches divided by 2 equals this run. So that's important. Let me show you why. We can go 9 feet, 11 inch, 1/4 run, 8-inch pitch diagonal. So the rafters should be 11, 11, and 5/16. So all these dimensions you see, these are horizontal dimensions. They are not actual real dimensions, like along the angle of the rafter. These are all horizontal because you'll see here in a minute what goes on. Now, these numbers that show up here, this is from using a macro to give me length and to give me center line length, because I didn't know which either one of those meant. But you go into object specific. Here's your different options you can play with. Okay, so cancel. So, and for some reason, I know Eric has a video that shows how you can convert these by using a .to something and turn these into actual feet and inches. That would be useful. I'm not sure why it defaults to this, but whatever. So what it's saying is Chief is telling you that this rafter right here is this long, which is length, or this long, which is centerline length. And what I don't understand is they're different. So that's the first thing. Secondly, I'm going to convert this length into inches, and neither one of those numbers match this number, this 143 and 5/16. That's the actual rafter number. That's the common rafter length. And so when Larry and I were talking about this, here, I'll put this over here for a minute. This is how you frame a building. Outside of framing, to the face of the ridge, there's your run. And like I did with the Construction Master calculator, I input that as the run. And then I do the pitch, which this pitch is 8 and 12. And then that'll give me the diagonal, which is the length of the rafter. So what you can do if you are a super sleuth, you can clear all this. And I found that if I entered 150, not right now, I'm not, 159 inch and 17 30 seconds, which is way beyond my framing tolerance, as a diagonal, and 8-inch as a pitch, then I get a run of 132 3/4. So let's convert that to feet and inches. 11 foot 0 3/4. All right, so where would I have that? Let's try from the face of the ridge to the outer part of the, oh, look at that. So there you go. What's going on here is this number, 159 and 17/32, is actually, let's draw it with like a bounding box. Here's, come on, work with me. And to make it visible better, we're going to open up that, and we'll do this, and we'll do that, and we'll do this, and we'll do that and this. Well, not quite. Hatch angle. We'll do this and that and this. Okay. So what Chief is doing when they say center line dimension, that's from the face of the ridge to the inside of the subframing, like the subfascia, this 2x4 that's nailed across here, which creates this problem. From framing to over that 2x4, or whatever you're using for your subfascia, that should be your overhang. And here, this is a 16-inch overhang that I've drawn, and Chief takes it to over the actual fascia. And that's not how that's done. Normally, you're going to make ladder blocks out. You're going to have a nailer along the wall, you're going to have blocking, and then you're going to have your other 2x4 out here. And if the plans call for a 16-inch overhang, you're going to rip your plywood 15 7/8, and you're going to flush it to the outside of the blocks, or the main 2x4 block going along here. And you'll have like a small little gap along the wall, and it's 16-inch is over the framing, and then you apply your fascia. And in this instance, that's 1 inch. We do that up here in the Pacific Northwest. But we don't do closed soffit, so anyways, this is more like a Southern Texas thing. So now I know what Chief is doing is measuring this number they give you, this center line length, is from the face of the ridge all the way out to the end, just like this shows. Now, let's see if that's accurate, because if you do a jack and you're measuring the center line, you're down here, so you're actually short. So let's first measure let's measure this. See how it snaps right there? I want it to snap right there, and there is no blue snap, but you notice I can make it snap there. And then you got to roll out over so quite slowly, but you got to hold your mouse button down. Come over here. Okay, so there's the horizontal length of the roof. And if I take my calculator back here and go clear, we'll go 8 foot 7 inch 11 16 run 8 inch pitch diagonal. Oh, and then of course convert it. This is where I'd like to either be all one or all the other. So it should be 124 5/8. It's not. So then I'll go, okay, well, if Chief is always measuring from some point to the inside of the subfascia, let's try this number, because that'll be long point to the inside of subfascia. And I just have to comment, nobody does this. Normally, you're going to pull from the face of rafter down to the outside of the wall, because that's the span. And then if you need an overhang, you'll have a tail pattern that you line up with this plumb mark right here on the board you're laying out and trace out the tail. I suppose you could do the whole rafter and then slide your tail pattern to that point and then work backwards. That's a viable option, but that's not the way I've done it since 1989. So just saying. So 9/9, let's go back to that. Nine foot 9 inch 3/16. Run 8-inch pitch diagonal. And then convert to inch. So it's neither one of these. Centerline length. Oh, you know what? Now I get it. Centerline length. They're going down the center of this jack. And that's going to cause you problems because not all roofs are common. Over here, you got a 12 and 12 and a 8 and 12. So you're going to have all kinds of chaos. So they have no cut sheet capability. Like you can't just go over here and just say, yeah, here's your lengths, cut them, because they don't work. And that's where we bring in AutoCAD. Oh, before we do this grand entrance, there's a couple things that Chief does that are just non-standard, not right. All right, did anybody see it? I'm going to come over here and show you over here because I got color over here. Anybody see it? Anybody see it? Anything wrong? Okay. See this? 9/11 and a quarter, which is the span, subtract the ridge, divided by 2. Right there. So why is this rafter in the middle here? Because this common, main common, should be identical to this end common. These are both 8 and 12, and this is a 45-degree hip. So I know what they're doing. They're trying to follow the theoretical string line, but it's not right. Not when you have 3D thicknesses. What has to happen, what is supposed to happen, is this goes to there, and the ridge comes to here. And that's how you get the proper ridge length. This is it. This is how it works. If you wanted to make this work in the field and be like some kind of super stellar framer, you would even rip the 8 and 12 bevel on both sides of this, and then you would do the 8 and 12 across the end, and you would actually, this would be sloped in 3 directions, and then this is how it would go together. Common rafter, common rafter, common rafter. So when Chief tells you it breaks in the middle, and then they give you this dimension, here, I've kind of got it fixed here. Yeah, so it's, what you really need to have is this goes to there. That's the true ridge length. But the ridge length they give you with that line in the middle is 1.5 inches short. So that's another thing that you can't cut to make this work. But here's how you would do it in AutoCAD. Yes, AutoCAD is not as 3D model-y and, doesn't work that way. It's just 2D lines. But this is actually how you would frame. There's the ridge. It's pocketed by 1, 2, 3 commons. There's that same run. There's that same horizontal run that we had before. And it works out to be the actual rafters are 11, 11, and 5/16. And I guess I could convert that for everybody into inches, if you're liking inches for whatever reason. 11 foot 11 inch 5/16. convert inch. 140, yeah, there's that number again, 143 and 5/16. So, and this blue line is a 16-inch overhang. So, let me just explain some things. This is feet, inches, sixteenths. Anybody who's ever set a truss, the truss manufacturer's documentation will provide the lengths in this format. And if you're a framer who doesn't like to change, then turn away. But this is a viable measuring system, and it makes calculating these things way easier for me. That's why I did it, because I didn't know how to write the steps necessary to convert it into fractions. It's not something that I wanted to spend time on. So this is just an array. It's like a matrice or a matrix. And this is, you enter the information this way and it gives it back to you. So I just got used to reading it. It's real clear. That last number is always a 16th, 15/16, 0/16, 14/16. And if you think about it, it's pretty easy to understand. For the overhang to be the same all the way around, the hip on this 12 and 12 side does not go to the corner. Now, when I first started framing in Texas, for us to get the overhang to be the same, and we would run that hip to the corner, they would bobtail cut all these rafters, which means they're cut right down the plumb line on the outside of framing. And then you would take the tail pattern and you would cut a bunch of 8 and 12 tails and you would nail them beside these 12 and 12 rafters. And it creates a little slope from a 12 and 12 to an 8 and 12. Kind of looks like a Pizza Hut roof or Witch Hat or something. And then people started demanding the same overhang all the way around and the same continuous roof pitch down. And the only way to do that is to raise the steeper pitch, and that's a calculation that can be made. And when you raise it, as you raise that wall, like this group of walls right here on the left, as you raise this wall, as you balloon frame it, naturally the hips come in from the corner for every, like it's based on the pitches, but in this instance, it needs to be raised by 5 and 5/16 inches along this wall. And that way, at that altitude or elevation, the hip will land. It's actually like 7.999 something. So it rounded up to 8 inches in from the corner. And then these are your values for your jacks. And they'll have a 56.3 degree bevel at the top. And then here's your information for the 12 and 12 jacks. There's the increment. It's always good to have that information. And then if you want to rip these hips down the top so you don't have to drop your hip, and we'll talk about that in a second, then you would rip the 8 and 12 side. You'd set your saw on 17.92 and you would drive down the middle, depending on which side of the saw the blade is on. And you flip around and you'd go 36.04. And then your plywood would plane right to the center, right to this center line. This would be beveled at 36 and this would be beveled at whatever, 17. And then your plywood would come across and you'd be following this perfect peak. But nobody does that because framers don't get paid enough to take that kind of time. But if this was a really wide hip, let's say this was a really long span, 3.5 inch beam that they wanted to clear span a long space, it's worth ripping the top so that it just fits better. Yeah, the main common and the end common and the main common and all these main commons, they're all the same rafter. So, and then on this end, this is a different end common because it's a different pitch. I'm trying to think of what else I would want to say about this. These numbers are, this horizontal is the exact same as chief. 8, 7, and 11. 8, 7, and 11. So Chief's getting that correct. Well, actually, no, I take that back. Chief is dimensioning to the inside of the subfascia. So I don't understand that. That's not a true accurate measurement. So if they want to leave it, like say this is this length, 11, 0, and 3/4 is the center line. That works perfect for boards that butt into something square because that whole top edge isn't changing. It's not on an angle. And they can leave that, but they need to call it something else. They need to call it total rafter length or, I don't know, something. Because I know they've got the ability to write the equations to subtract. However, first this has to get fixed. 16 needs to be to the outside of this 2x. So like where 15 is, that should be 16. And then once that's fixed, then they would be able to say this number here minus overhang would get this arrow back to the wall. And then they would do the calculation of that's the run, here's the pitch. And then the diagonal would be a number. And they could call that rafter length. And it would be rafter length to the outside wall. And you just have to explain to people, when you say rafter length, that's the rafter length. And then this other little length, that's the tail length. And yeah, they're all part of one board. But when you hook up here, you come to the outside of the wall. You don't go all the way to the end of the tail. So this is not correct here. And I know why, because it was like it's actually like 140 and something. And like we discussed earlier, this center line is actually down the middle of this board. And it needs to be to the long point. So that's what I would recommend they work on, is making the lengths correct, that you could use this as a cut sheet. Because this would be perfect. If this said rafter cut sheet, and all the rafters were labeled, and they can have like little icons, and then somebody come along and say, hey, I've got 24 of these all the same length, and they come over here, here's 25 actually. Isn't that funny? I changed this one and it became 25. If I put it back, it's going to be 24. Okay. Yeah, so that needs to go here. So I've got 25 rafters, and if I cut them all 13, 8, and 3/8, they're going to be wrong, because that's not how you do it. So I want to be able to have it go from face of whatever thickness this ridge is, and that's in the database too, because you pick the ridge when you design the roof. So you could have a 3.5-inch ridge to the outside of the wall, and that would be rafter length. And then you could have another one that said from wall to over subfascia. Actually, no, correction. From wall to inside subfascia, and then that would be tail length. And then you would take those two numbers and you would round it up to the nearest 2-foot interval, and that would be the material length of what you would order to cut that board or whatever it is you're fabricating. That's how you would get the nominal lumber length. All that's in the database. I just don't know enough to help you guys figure that out. But I know I can do it in a calculator. And maybe with Larry's help, I'll figure out how to do it in Excel. Because then we can print a PDF and put this information somewhere on a plan, where if the person building the project makes the walls land where the plan says they should be, i.e. the spans all work, and like all aspects of a roof, everything's driven by the ridge. So if you have a very complex roof with a bunch of different ridges, as long as all those spans that are connected to those ridges are framed correctly, then all the numbers provided, you could just cut the roof on the ground. that's just, let's see if I can find something here as an example. Let's go over here. Yeah. Where's roof? Give me just a second. I don't know if this helps. Yeah, the same thing here. It's just a different view. I was going to show you how I used to cut roof. But these are the things you need to know. Whoa, come here, you. You need to know the span. You need to know not necessarily the half span, that's just the middle. The calculated run, or just run or whatever. Your overhang. And see how the overhang is over the subfascia? That's how it's always been. It's not over the fascia. I wonder if I could. It doesn't zoom in the same. That's how that goes. And common rafter is blue because it's the same as the main common rafter. And this is a common, all the same pitch roof. It does change when you have the other styles where they're irregular pitch like this. It's totally. I got to tell you a funny story. Had a young superintendent walking the job, and he wanted to talk to me because he said I screwed up the roof, and he was all trying to bow up and act all mad. And he said none of the jack rafters lined up on this irregular pitched roof. And I stood there and I looked at him with the look of, I don't even understand what language you're speaking. And then he got even more bold and said, well, you don't understand what I'm saying? And he says, at the top, they're supposed to line up. And so I said, yeah, if it was the same pitch on both sides, it would line up just like how you see here. And so he's like, well, I want them to all line up because this doesn't look right. And I said, okay, you realize what you're going to do. These are both 16 inches apart, going in two directions. Which ones do you want me to line up? Do you want me to line up these on this side? Because now you're going to be like 10.5 inches or whatever to line up on every one of these. It's not going to be right. Or I could spread these out and line up, and then you're going to be some really wide number. And he didn't get it. He just walked off. I don't know if he went to complain to somebody or whatever, but it's funny to see some people how they handle things that they don't know. Instead of just saying, hey, so what's going on here? Why is it like this? I would have told him. But, you know, some people are afraid to just have a little humility. What I wanted to show, I can't seem to find. I wanted to show you how I would cut a roof. And I think I've probably shown this in a few other videos. Still looking. Where would that be? I think I just sent it to somebody. Let me try something. Open up the email. Go to sent email. Yeah, let's try this. Here we go. Yeah, so I actually did this as a framer the night before. I would draw out the roof. It would take me, like a roof like this would take me 4 or 5 hours. And I would run my calculator and check the spans. And so here's how I break this down. Everything is based off ridges, so here's all your ridges. And I would get the span for each ridge and the pitch for each ridge. And then I would start calculating and putting in information. And so it can be done. I cut this whole roof on the ground while the guys were finishing joisting and doing other stuff. And I had one helper who would, you cut a whole section and you drive a nail in the upper tip, like up here, and another one so that you could hang these on the wall where they go. And then when the guys are ready to come over and start raising roof, they have everything hanging on the walls all the way around. And then they just go. We just start with, hey, let's get this main roof up. Hey, let's do this roof. Part of this valley was a true valley. And then once it got outside to the porch, then it became a lay-on. So you just have to know what the plan is. Like these rafters go all the way under to the wall where the covered porch was. But all of these are easy. Every one of these lengths is exact, and it worked. It's how I always used to do it. So this is what I want to provide. I want Chief to provide this. All this information is in the database inside Chief, and they just need to. Here, if they need a test example, I will draw something and get it to them. But I would love for Chief to be able to do production drawings because it would just make life simple. So I know there's people out there that are, do you want to take the liability for that being wrong? You put a little word down here that says the builder is responsible for all things, and if the building is not constructed exactly to meet the dimensions, then none of these numbers work. And that just, it's an incentive for the framer to nail it, because then all the thinking's done and he can just go fast. But I don't know. Anyway, so that's that. I just wanted to show the differences. Larry contacted Chief and showed them. Let's go over here. Showed them this issue about the end common being 3/4 of an inch horizontally longer than it's supposed to be. And this is exactly what Construction Master does. They do the same single line string to do their calculations. And that's why Construction Master is wrong on their jacks. And you'll see it even more wrong if you use an LVL hip or if you use a really thick ridge. It gets even worse. And I have a video on that. I went like 3 videos deep on that because it always frustrated me when I would run plywood and I'd get to down here in the corners and the jacks are crooked compared to the 4-foot edge of the plywood. And I would be like, man, we followed the calculator. We cut exact. We did really tight framing. Why are these jacks not perpendicular to down here so that the plywood is square? And I never figured it out until I started programming my own calculator, and then I realized they're not factoring in the thickness. And it's the thickness in this direction up to this center line on the slope of this pitch. That's what you have to factor. So anyways, I think that's it. I would love to have this table. Roof frame, here's the numbers. I'm sure I could. I wonder if I could turn the label on. Let's see. Labels are on. How come I'm not seeing? Oh, I know what it is. I know exactly what it is. I am only. Is it here? Yeah. Use both label and call it. Let's see what this does. This could get scary in a hurry. Owie. Yeah. Okay. We're going to fix that. We're going to fix that to be like 3 or 4. Let's try that and see what that does. Nope, that's still. Oh, and you know what? That means let me try a smaller font real quick. No, that didn't work. All right, well, that's a mess. I wouldn't want to read that. Skip that. Yeah, so what I would do is if it would be like notes. If each unique rafter started like 01, 02, 03, 04, 05, and then the opposite ones they would be the same because you get two of each of these, two of each of these. Then you could come up with some numbering labeling system that would be real clean so that as the guy's doing 25, like you're going to cut all your long stuff first, right? 25 of these, and they're going to be not that length. They're going to be the right length. And then he's going to put his tail pattern on them. That's the kind of information we're looking for. I know it's doable, and I'm willing to work with Chief, no charge, to see if you guys can get it to match reality. This is dumb reality. This is just 2D lines, but this is very accurate. This is the way it would be. It's correct. You have all the numbers and all the data in this database. We just need to get the right configuration so that Chief can do this. And then that would be amazing. So thanks for watching. And if you have any comments or questions, send them. Maybe we'll do some custom CAD work somewhere for somebody just to clarify something. I don't know. Let's see. I got to find the off button. There it is.